Hello everyone, welcome to the third and final installment of a video on the rest of our week 4. I'm trying to say week and I keep trying to say chapter instead, but week 4. Let's fire it up here. We got through Whelan chapter 4, Huff chapter 8, talked about a lot about that, and now we have some examples about correlation. So hopefully what you've gotten by now out of our discussion has been the idea that we're interested in correlation because correlation occurs when we have a causal relationship. When we have one thing causing the other, we can very often observe that relationship by one variable moving with the other variable. Let me get my head out of the way here. There we go. I hope that's okay. The crop I'm viewing has a bright line around my head, but I think it looks, yeah, I think it's doing okay. All right. So we should appreciate by now that when we're interested in correlation, because two things that are related in real life very often show that relationship by being correlated with one another. So for example, we would expect there to be a correlation between the amount of time spent studying and the grades that one earns. It's not perfect. Some people hardly study at all and get high grades. Some people study a great deal and only get middling grades. But by and large, we see that the more people study, the higher the grade they earn. Similarly, we expect to see a correlation, and the reason a lot of us are in school, I presume, is we see a correlation between the number of years one spends in school and the income one makes after school. So we assume that the years of schooling is causing the higher income out of school because presumably the skills that we're learning in school are translating into higher earnings later on in life. So that's why we're interested in correlations, is because correlations very often are related to something that's going on where one variable is causing the other. However, a lot of the cautions, including the Huff reading that we've been encountering, is that correlation does not equal causation. And that is that we see spurious correlations or accidental correlations quite often. So then, if we can easily dismiss a correlation, seemingly easily dismiss a correlation with a bit of a pff and a comment like, well, correlation doesn't equal causation. If we can just wave away any correlation we see, then what's the point in a correlation? And the answer that we got to in the last lecture was, we're interested in correlations because they can tell us about a causal relationship if we have a clear explanation of what's driving what, if we have a rational hypothesis. And a little bit of this is in the eye of the beholder, because stuff that seems common sense to some people isn't common sense at all to other people. As a matter of fact, sometimes people take a spurious correlation and say, look, there's causation because it's common sense. But we do need that. We need to have some kind of a reason to believe that one thing is causing the other. In the absence of a credible explanation, then we're really just we're just grasping at straws. We're looking for evidence where there's relatively poor support or poor evidence. Let's look at some examples of where correlation might be useful and also where correlation has gone wrong. And so we're going to open up this excellent blog post by Bethany King. And I'm going to summarize the problem that we had here, but the problem that we had here is one from medical science, and this is where we really have to be careful with correlations, because it's very easy sometimes to assume that there is a causal relationship and in fact be wrong about it. This is a classic example of medical science being misled by it's not a spurious correlation, but it's actually a reverse causation case. So I have a hard time using the right terminology here because I'm not a medical doctor or a disease specialist, but the story here is that there's this issue of preeclampsia, and I'm trying to. So sorry. So you really, if you really want to get into this, there's this story here about pregnant women dieting, and then there's a story here about this. This little blog post gets into the meat of the issue. So I want to explain it to you without having all the text up here, because I know that the text is distracting you from the story, because you can't read and listen to me at the same time. You can go back and read the blog post. It's very short, and the important part was down there in the discussion part, which is that there is a dangerous medical condition associated with pregnancy. And I'm going to find space here. I want to make sure I have a plan to make it all fit. Let me think about where I'm going to put this. You can watch me thinking in real time here. It's a painful process. So there's this condition called, oops, I didn't realize it was that far over there. Okay. Let's move over a little bit. There we go. Okay. There's a condition called, boy, it's going to be a minute, folks. Just hold your horses. Got to calibrate my pen and my writing here. Preeclampsia, and I want to make sure I'm spelling that right. So, yes, okay. If we were fancy, we'd put a little umlaut on the second E, wouldn't we? Because we want to make sure it's pronounced. But I'm actually going to neaten this up because this is a hot mess. There we go. Okay, preeclampsia. This is where I get to take off my I'm a doctor PhD hat and acknowledge that I'm not a medical doctor, so I don't know much about this, but I know about the example, so we're going to get into that. Preeclampsia is a dangerous medical condition for women that endangers both pregnant women and the life of the baby, and requires serious critical care in a lot of cases. So it's not a small thing. And prior to modern emergency medical care for pregnant women, and we've done a lot to advance saving lives around pregnancy and around childbirth in terms of all these dangerous conditions that come up. But in the first half of the 20th century, there wasn't that much technology around to save pregnancies that were going this way. So preeclampsia was seen as a dangerous condition that was to be avoided if possible, which makes sense, right? One of the things that doctors observed was that preeclampsia was when women came into the hospital and were in this condition, in this status of being in preeclampsia, one of the things that they noticed was that women had just put on a lot of weight. And so what the doctors said was, they said, well, the women started gaining weight, and a lot of weight, sort of a remarkable amount, in the week or two before they became preeclamptic. And so let's put and so what I'm saying is they saw a correlation that a lot of the women, almost all the women, in fact, who came in with preeclampsia had gained weight, gained a fair amount of weight. And so doctors in the 20s and 30s said, oh, well, look, there's a correlation. Women are gaining a bunch of weight, and then they're coming to the hospital with preeclampsia. So the logical conclusion is that weight gain causes preeclampsia. That's that arrow I just drew on there, right, in a causal pathway, that weight gain causes preeclampsia. So the logical conclusion of that is if you want to prevent preeclampsia, because medical technology didn't have much to do with it, right? There wasn't good emergency care at the time for preeclampsia. There was very little they could do once somebody came in with that condition. And again, I'm not a doctor, so I'm painting with a very broad brush here, but I hope I hope I'm communicating at least the broad outlines of this to y'all, because this is the important part. So if weight gain is causing preeclampsia, then what do? Well, we combat weight gain in pregnant women, and sure enough, that's what the recommendation was. And doctors in the 1930s were nervous about weight gain because they wanted to prevent it. They wanted to prevent this dangerous condition. So the medical recommendations prior to us figuring better things out, and I don't know when the transition happened exactly, right? But limiting weight gain would prevent preeclampsia and would also have women not gain as much weight, which was a very tacky early 20th century phenomenon, right? So doctors actually recommended that women who gained weight too fast while pregnant go on a diet. That was the medical recommendation. That was fairly standard in the age. Now, what's the problem with going on a diet when you're pregnant? Well, you end up with a higher rate of disability in children. It's unhealthy for a fetus to have a dieting mother. They need all the energy they can get. You're growing a baby, right? So this is a great example of reverse causation, because what we know now is that preeclampsia wasn't caused by weight gain. Preeclampsia was causing sudden weight gain. And a lot of it had to do, from my understanding, again, not a medical doctor, with the sudden increased retention of water. So women would gain a lot of weight and present at the emergency room very heavy because they had already started preeclampsia. So the doctors had this exactly backwards. Preeclampsia and weight gain are a correlation. There's a correlation there, but they had the cause and effect reversed. And when preeclampsia causes weight gain, you don't worry about the weight gain. You worry about the preeclampsia. If weight gain was causing preeclampsia, then you worry about the weight gain. But it doesn't work that way. So this is where we have to be really careful. This is a good cautionary tale about confusing cause and effect. Hopefully that was not too painful to work through, but I didn't want to read you the whole blog post. Let's move on here. Another example is this story, and I'll have you read the whole story, but I'll give you the short version. I'll draw causal diagrams for it as well. The argument here is that parents' lives are made more miserable by the Boomerang Generation. The Boomerang Generation being kids who move away but then return home after being away. So a boomerang kid is a kid who moves out and then moves back in. Now, by the way, I recognize that we're in a time when a lot of young people are moving back in with their parents, and in fact, some good friends of mine have had just exactly this happen. They've got I think 2 of their 3 adult kids, maybe 3 of their 3 adult kids, living in their condo. It's a friend of mine who's a retired professor of geography and now has a bunch of kids living at home with him. They are pretty accommodating and understand it's an emergency, but I'm not trying to make you feel bad or guilty about this. And as a matter of fact, I think it's going to happen a lot. The one lesson to take from this is if you're someone who has returned home with your parents, you might think about the effect of returning has on them, not just on you. And I realize it has a lot of effect on you as well. So just try and be mindful of all that if we can, and everyone be kind to each other if we can. Here's what this article is saying, and the article does a great job. It's very well written, I have to say. And reporting doesn't always do a great job of reporting what a correlation means or does. And so I'm checking the time, sorry. I gotta make sure I give my spouse a break with the kids in a minute. But here's what the article is saying: it's saying that there's a correlation, an observed effect, uh, and I use effect being in the sense of like we see a correlation. We don't know what's causing what, but I'm going to use a term, kids return. Whoa. Come on, buddy. The feedback is a little slow between the pen here, so let me see if I can just do it with single. Yeah. Am I gonna do it? Can I do it? Can I do it? Can I do it? I can do it. Good enough. There's a correlation between kids returning and a presumed cause. We're going to just put that out here. Throw caution to the wind. And I'll draw another box. Here. And what am I going to call this? Are parents' lives made more misery? More miserable? So I'm just going to say... It looks a little bit like an R, but it's a P. Rarent. I wonder if I couldn't actually type this stuff faster, but I don't know how to do that in Keep either, and I can't draw arrows as easily, so this is what you get. I'm going to say not misery, because that's a strong word. That's a clickbaity headline. Unhappiness. Okay. Parental unhappiness, or parent unhappiness. Now, right away, though, the article does a great job of talking. It's summarizing a research study that looked into this in the United Kingdom, but I think the results are fairly generalizable because the story makes sense. Returning kids are associated with parental unhappiness, and I drew the presumptive causal arrow there. But how do we know, for example, that it's not... in the age of the study was done in the post-recession economy, when a lot of young people who went out into the world and then got hammered by the 2008-2009 recession ended up moving back home. And so how do we know, for example, that there's not some X factor causing both the kids to return and I recognize that this is barely legible if that chicken scratch, but hopefully you get the idea. And then also causing and also causing parental unhappiness. In other words, what if X here, if there's a common cause like financial trouble? So a kid losing a job in the middle of a recession, or at the end of a recession even, and being forced to return home would be caused by the recession. And then maybe the parents are unhappy by that as well. Like recessions don't make us feel positive about the future usually, right? They make us feel a little bit sad about the future. So maybe that's what's going on. Maybe it's something about the circumstances that led the kids to return that make the parents feel unhappy. Or maybe another hypothesis would be, maybe it's not the kids actually being at home that's causing the parents to be unhappy. Maybe X factor is well, I'll just use this diagram because this is fine. Maybe the X factor is the kids relative lack of success. So the kid hits a hard time. Maybe that's both leading the kids to return and leading the parents to be unhappy. But it's not, the parents aren't unhappy because the kid's living with them. Maybe the parents are unhappy because the kid had a tough streak, right? Maybe they're worried about their kid's future, and so that's making them unhappy, not the kid being at home. So the question whether we can tease out whether it's the kids returning that's causing the parents' life satisfaction to decrease, or whether it's something else that's causing both, and there's really no causation. The interesting way here that they got to the bottom of that, they teased out this difference, was that they looked at kids who returned to an empty nest and compared the parental satisfaction with families where kids also returned to a household where there was a younger sibling. So in other words, they looked at exactly this bottom characteristic here. If it was some external factor causing both the kids to return and the kids to be unhappy, maybe on the kids' behalf, maybe just about things in general, right? Then it shouldn't have made a difference whether you already had a younger sibling at home when you return home yourself. But if the kid returns to an empty nest, that is, the parents were alone, living alone, and then they had a child return, that's different, right, than if they already had a kid staying at home and then another kid came back into the house. In other words, what they were evaluating was, did it matter whether there was already a kid living there and you didn't have an empty nest and another sibling came home? If it was an outside factor, if there was an X factor causing both your unhappiness and the kid to return, then you should have seen your parental satisfaction go down, right? The same as if you had an empty nest and a kid came home. What they found was that parents who had a kid come home with a younger brother or sister already in the household didn't experience a decline in parental happiness. But those who had an empty nest that did have kids come home experienced a decline in parental happiness. So the conclusion that the researchers drew here is that yes, in fact, it is the kid actually being back in the house that causes a decline in parental unhappiness. So this is one of the ways that researchers are really clever about unlocking a cause when somebody else could just say, well, there's something else that could be causing it, right? They're teasing apart, they're thinking about the correlation analytically and critically in a way that they can differentiate between possible causes by comparing families that had a sibling at home to families that didn't have a sibling at home, both families which had a child return. Okay, so I thought that was really interesting in getting at this problem of causation and correlation. A couple more quick ones here. I spent a little more time than I might have needed to on that one, but we'll get moving. This is a quick example of just what we'd call a back-of-the-envelope correlation. This is by Philip N. Cohen, who's a sociologist at University of Maryland. Interesting fellow. Does a lot of family sociology. And can I blow this up? Can I zoom in on that? Oh, it's still tiny. Let me see if I can, hold on. There we go. That's better. So what Cohen's looking at here is, and you're going to do a similar exercise for your homework 3. So that's coming, your assignment 3. So that's coming up. What he's looking at here is divorces per 100 adults, and the divorce rate is somewhere between about a half per 100 adults and 1.2 per 100 adults is a percent of divorce rate. And this is per year, right? So 1% of married couples get divorced in any given year is what we're saying right there. And then this is a Google search result by the state level for vasectomy reversal. And what Cohen's he's just sort of noodling around here, and he says so in his blog. He's like, well, a correlation is a place to start. And that's another use of correlation, by the way. So we talked about correlations indicating there might be a causal effect. Sometimes we find a correlation and we say, and it makes us think about what might be causing that. It helps us generate a hypothesis that we can then test. We don't want to just conclude anything from finding a quick correlation, but we say, I wonder if this is an accident or if maybe something's going on here. Let's investigate. So Cohen uses this as a jumping off point for maybe we could ask this question. But what this correlation seems to be implying is that the divorce rate is correlated to the Google at the state level. Divorce rate at the state level is correlated to the searches for vasectomy reversal on Google. In other words, people are searching for how to get a vasectomy reversal more in states where the divorce rate's higher, and is less common of a search in states where the divorce rate is lower. So then why is it that people will be searching so much for vasectomy reversal in places where the divorce rate was high? And Cohen hypothesizes that it's because it's fairly common for people who divorce and then remarry. It's most common for divorced men to marry someone younger than them, and on remarriage, and then it's common for marriage as well, but more common in remarriage as well. And on remarriage for in heterosexual couples for the wife to want to have kids, and so that's not unusual. So here we have some credible evidence, maybe implying that it turns out that there's a number of men who have had a vasectomy, have thought they were done having kids, but then, as shown by the divorce rate being higher in some places, those places where more men are getting divorced, heterosexual men are getting divorced and then remarrying, there's more interest in vasectomy reversals because there's interest in having more kids with a new spouse. So thought that was interesting. We're going to go into that in more detail. And then cause and effect of myopia. By the way, this is something that was brought up in this TED Talk that I had you look at, but the cause and effect on myopia is quite interesting. And I'm going to draw a causal diagram for this as well, instead of reading the whole thing. So again, you read it, and that's fine. But it's quite an interesting case of science changing really fast, where there was a study, and they did a survey study about kids coming into an eye clinic. Kids had myopia, and myopia is nearsightedness. You can't see things as well close up, right? Wait. I think I got that backwards. Hold on. We're going to ask the Google, because I don't want to be wrong. I hate being wrong. Nearsightedness. Myopia is you are nearsighted, meaning you can see things close up. You can't see things very far away. I had that backwards. There, I was wrong. By the way, one of the readings from last week was about bullshit, and we didn't talk too much about calling bullshit, but one of the best indicators I know of finding bullshit, detecting bullshit, is show me someone who has never admitted to being wrong. And I will show you a bullshitter. Not a big deal to be wrong about myopia, I hope, but I've been wrong in other ways. Except, actually, if you ask my wife, she will tell you I've never been wrong, but yeah. All right, let's get into it. So, that was our fun little interlude. Let's get back to talking about this study. So, legit, honest, scientific study looking at the causes of nearsightedness, myopia, in children. And what they found was that families that reported that they had a night light on in the house I'm going to draw a circle. Nightlight use was correlated with young children. Oh, whoa, wait, that was weird. fix this. Give me a second. The tablet was supposed to be scrolling every time you push on it, and then suddenly it wasn't working at all, and now suddenly it's working. Did the D not get written? Why is that D not writing? The struggle is real. There we go. Childhood myopia. So they found that, oof. Man, if I could, I wish I could just set a camera up with a piece of paper on it so I could doodle, but that would be, my technical limits have already been reached. This is good enough. The nightlight causes childhood myopia was the researchers' first conclusion, because they found that that rooms that had more nightlights, or families that used nightlights, had kids with myopia, and that families that didn't use nightlights had kids with more normal vision. So they said, wow, if we have nightlights and kids' myopia, then boy, we better not use nightlights. So there was actually a very briefly published paper saying, we found this correlation, holy cow, we don't know what's going on, but stop using nightlights, right? Really good example of using a correlation as too much evidence by itself. The paper that wrote that acknowledged that they didn't have any kind of a causal mechanism. They didn't know what was going on to cause that. And so what they actually found was that there was an X factor, which was the parent's myopia. And the parent's myopia caused both the use of nightlights and, through genetics, caused myopic children. So in other words, if I have myopia, if I have nearsightedness, it's genes. My genes get passed on to my kids. I'm more likely to have a kid that has myopia, right? If I have myopia, I take my glasses off or I take my contacts out at night, I have a hard time seeing. So what do I do to get around the dark room at night? I turn on a nightlight. So being myopic means I use a nightlight and I have myopic kids. And this is just a brilliant example of one of these common causes that leads to, was originally interpreted in a very different way, like, oh, stop using nightlights, it's hurting our kids' vision, right? When in fact it was something totally different. All right, the last thing I got in here for us is this acetaminophen and asthma point. And sometimes it's really hard to do double-blind controlled tests. In medicine, we do see them, but this is a great summary of where a lot of correlations all point in the same direction. And importantly, not just lots of correlations that could be spurious, also that that there's a plausible causal mechanism. So I'm not going to read it to you here, but you can look at this list. There's 7 different points here, right? And what I want to, so there's 1, 2, 3, 4, 5, and 6. There's a couple things about double-blind studies in there, but most of 1, 2, 3, 4, 5, and 6 are all correlations. It's like we have a correlation this way, we have a correlation that way, we have a correlation the other way. So a bunch of correlations all pointing towards this relationship between using Tylenol, acetaminophen, and developing asthma as a child, right? And then what I want to point out here about this is, last but not least, number 7, the biologically plausible mechanism of whatever, glutathione depletion in airway mucosa. That's the science part of it, right? But the point of this is they're saying, look, there's all these correlations, and we have a mechanism. We have a causal story. We can tell you what it is about the body that using this drug would lead to this symptom. In other words, it's not just sort of like, we don't know why nightlights just cause kids to go blind. Like, that's not what we're talking about. We're talking about we have a mechanism. We have all these correlations, and we have a way to explain the correlations. So hopefully that has reinforced this idea about correlation being a useful and powerful tool, but also having some pitfalls about interpretation or overthinking or maybe underthinking, not thinking critically enough about them. I'm going to end it there. I'm going to come back in a little while and do a dank data memes, and I also need to present assignment 3 to y'all. Bye-bye.